In this lesson, we're going to look at the reactivity series of the metals. First of all, let's have a look on the periodic table and remind ourselves which elements are metals and which are non-metals. So we have a staircase coming down here, starting between boron and carbon, right? And roughly the separation between the metals and non-metals follows this boundary. Now, you may have remembered from an earlier lesson that the reactivity of the metals decreases as you move up the group. Right, so we have decreasing reactivity moving that way, and also as you move from groups 1, 2, 3 to 4, we have decreasing reactivity moving that way. So let's just remember, we're talking about the metals here, and we're looking at decreasing reactivity. Okay, what actually affects how reactive a metal is? Well, that's to do with its atomic structure. Again, you can go back and have a look at the lesson on atomic structure and reactivity in the section on atoms and elements. But the reactivity depends upon how easily an atom can lose electrons from its outer shell to form a stable electronic configuration. So what the metals want to do is to lose their outer shell electrons in order to form a stable electronic configuration or electron configuration. So looking at the group 1 elements, we remember that each of these have one electron in its outer shell, and potassium is able to lose that outer electron easier than sodium, and that makes potassium more reactive. Now, what I want to do in this lesson is present to you a series of useful and important metals and arrange them in order of reactivity. And so we've got this little rhyme here that can help us to do that, and this is one that I learned at school, and it served me quite well over the years. Now, you may not like the rhyme, or you may have some other kind of mnemonic to do that, but it goes like this: Kenneth never cared much about Zena, feeling so perturbed he could hug Agnes audaciously. And so the first letter in each word in the mnemonic indicates an element in the periodic table. And so first of all we have K, which is potassium, and then after that we have N, which is for sodium. And so what we're doing is we're moving down in decreasing reactivity. After that we've got Ca for calcium, then M for magnesium. Okay, so we started off in group 1, then we've gone over to group 2, and then over to group 3 we've got A for aluminium, and then Zn for Zena, for zinc, and then Fe for iron, feeling, S for, we're now in group 4, for tin, and then P and B for lead, and then I've got in red highlighted here H is for hydrogen. Now, hydrogen isn't a metal, as you know, but it's important to know its position in the reactivity table, and we can use this as a reference to help us understand how metals react with, for example, water or acids, and we will see that in the next couple of lessons. Then underneath hydrogen we have could, that's C for copper, not cobalt, right, copper, and then Hg for mercury, and then Ag for silver, and then finally at the bottom we've got audaciously, that's Au is for gold. So let's just highlight these metals again. We've got hydrogen, we're using that as a reference point here, and you'll notice that this reactivity series really fits in with what we know about the periodic table. So we've got at the top of the reactivity series we've got the group 1 elements. We have first of all potassium, and then moving up the group we have sodium, and then after that we got the group 2 elements. Those are the next reactive, so we have calcium and then magnesium, And then we move over to group 3 elements. We have aluminium. And then after that, we've got some transition elements, for example, zinc, and then iron. And then moving on to group 4, the group 4 metals, we have lead and then tin. And then, of course, we have hydrogen here as a reference. And then after hydrogen, below hydrogen, we've got copper and then mercury and then silver and gold. Now, there is one thing I'd like to point out about this rhyme, which is this, that when I learnt this rhyme, for some reason lithium didn't seem to be very important in those days. I'm not sure why, but nowadays it is, and lithium is included on the GCSE syllabuses. So we're going to have to include lithium in the reactivity series. So what you've got to do is, if you're going to use this rhyme, is to remember the rhyme, move it over, and then leave a gap for lithium. And lithium, as you probably imagine, fits in after sodium. As you would expect with the group 1 elements, you have potassium, sodium, and then lithium is the next reactive. So in the next few lessons, you'll see that in the reactivity series I use, that I have lithium here, which fits in here between sodium and calcium. Okay, so lithium is important in the IGCSE and the GCSE syllabuses nowadays. In the next few lessons, we're going to look at how the reactivity series helps us to predict how these metals will react with, for example, water, acids and oxygen. We'll also learn how we can use it to determine how to extract metals from their ores, for example, and whether one element can displace another element from its aqueous salt solution.